Hello, good day everyone. My name is Ray Flores and welcome back to my YouTube channel. For today, we will be discussing related rates problems involving cylinder. Last week, I have already uploaded my videos involving ladder and balloon. So if you haven't done watching it, the link of my first video about related rates problem involving ladder and balloon is in my is in the description box below. So the objectives of this video is the same as those previous videos, which is to the learner should be able to solve related rates problem, especially solving cylinder. And of course, be able to illustrate the given word problems and solve it effectively. But before I proceed in presenting the first example, let us first have brief um, catch up to the what is related rates. So related rates involves two equations, which is if we are going to solve any related rates problems, we are expect to solve for the rate of change with respect to time. So here will be the first example in solving related rates problems involving cylinder. So water flows 8 feet cube or 8 cubic feet per minute into a cylinder with a radius of 4 feet. How fast is the water level rising? So um, um, we are asked to find how fast the water level rising. So in short, we are asked to find the rate of change of the water as it is rising. So the equation we could relate it is the volume itself. So we have volume is equal to pi over r squared or radius squared height, which is the given. We have the given the dv or the derivative of our volume with respect to time is 8 cubic feet per minute and our radius, which is 4 feet. So assume that this is the illustration of the given problem, the cylinder, which is the radius be equal to 4 feet and the water or the height of the water, and we are looking for the rate of change in terms of the height with respect to time. So this is the given derivative of our equation, which is the dv over dt is equal to r or pi rather r squared derivative of h with respect to time. Just transpose and make um, just transpose or just additive inverse or multiplicative inverse to find or to come up with the derivative of h with respect to time equal to the derivative of volume with respect to time all over pi r squared, since we're looking for the rate of change in terms of height with respect to time. And because of that, we have already the formula we could use. So just plug in those values. So we have dh with respect to time all over 8 feet or 8 cubic feet per minute all over pi feet for pi quantity of 4 feet squared. So if we simplify that, we came up with the derivative of h with respect to time is equal to 8 cubic feet per minute all over 16 pi feet squared. So if we sub or solve or just simplify it, so we came up with the value of dh with respect to time or dh over dt is equal to 1/2 feet per minute. So as the water flows at 8 cubic feet per minute into a cylinder, which is the radius be equal to 4 feet, the water level or the rate of change of the water changed at the rate of 1/2 feet per minute. So let's proceed to another example, which is water is being drained out of a cylindrical tank with a radius of 12 inches. The height of the remaining liquid in the tank decreased by 3 inches per minute. How quickly is the water being drained? So this is our given, and the equation we could relate that given is the same. We have the volume, which is equal to pi r squared h, or the height. Given is the rate of change in terms of height with respect to time is 3 inch per minute, since we are draining the water from a cylindrical tank. And the rate, or the radius rather, of that cylindrical tank is 12 inches. So assume that this is the cylindrical tank, which is the radius measured 12 inches, and the water itself, the water is, we are looking for the derivative of volume, or the rate of change in terms of the volume of the water with respect to time, since we are draining the liquid inside the cylindrical tank. So our equation, which is the volume of pi r squared h, find the implicit differentiation or differentiate that equation. So we came up with the dv over dt is equal to pi r squared dh all over dt. We will not reform that, since we are looking for the dv all over dt. And because of that, just plug in those given into that formula we have. So we have dv all over, or equation we have. So we have dv all over dt, or the derivative of v with respect to time, is pi. Plug in the value of radius, which is 12 inches, and the squared, and plug in the value of our dh all over dt. The given is positive 3 inches per minute, but we plug in negative 3 inches per minute because of the word drained. Since it is being drained, so expected that the volume of the water inside the tank with respect to time should be lessen or decreasing. Next is just simplify. dv all over dt, we have 144 inch squared pi, since the square root of 12 inch is 144, and inch multiplied by inch, so we have inch squared into the pi itself. And then copy the negative, or bring down or copy the negative 3 inch per minute, and combine. So we have the derivative, or the rate of change in terms of the volume of the water with respect to time is decreasing to 432 pi inch cube per minute. So the water is being drained in the cylindrical tank with a radius of 12 inches is in negative, or is 432 pi inches cube per minute. And that will be all for today's video. I hope you like, and please do subscribe if you haven't done yet. Thank you, and bye bye.